Okay, hello and welcome to the next video in Pure, where we're looking at graph transformations. And this is again another very important topic in the A-level course. You'll see the concept of transformations in different aspects in year 13 as well. So in GCSE you've seen a variety of transformations. Most likely you've seen reflections, translations and enlargements, and rotations. We don't look at rotations as such at A level, but we do look at reflections, translations. We don't use the word enlargement at A level, we use the word stretch. Okay, so we'll go through all the different types, and one thing you've got to realise is that reflection, translation, stretch could happen in either axis, X or Y. And a lot of the time it's a case of recognising what's going on to the function that we're dealing with. So let's look at reflection first of all. If I have a function f of x and there's a minus outside it, that basically means that all the y values have been multiplied by minus 1. So the original graph f of x, if you multiply all the y values by minus 1, all those y values are going to be reflected in the x-axis. And if I've got f of minus x, that is actually the opposite to what you think it is. What's happening here is you've got the original function, but we're just changing the x-axis from negative to positive and positive to negative. And as a result, you have a reflection in the y-axis. This is a common theme that you'll see when you have something impacting the inside of the function, where the x is, then it's the opposite to what you think it's going to be. So here we have the reflections. Okay, so that's one group of transformations, reflections. You can also have a translation. So if I have a function and I add a number to it, what does that mean? Well, basically, if I have a function and I'm adding numbers, well, the y values will also increase or decrease depending what this number is. Yeah, the function will essentially move up or move down depending on what that number a is. Okay, so if you have a number outside of the function, you're adding or subtracting, that is a translation of the function with this vector. 0, which means no x translation, but a, which means the y translation. If you've got f of brackets x plus a, then that's a translation of f of x, but in the opposite direction, okay, minus a. So if you have f of x plus 1, then as we're going to see in some examples, the graph doesn't actually go to the right plus 1, it actually goes to the left minus 1. So again, whenever you see something happening in the bracket with x, it does the opposite to what you think it's going to do. Okay, so when you got f of x plus a, it's a translation in the x, but in the opposite direction to what you think it's going to be. Okay, so if it's plus a, it's minus a. If it's minus a, it's plus a. So these are all the translations as one group of transformations. The last one is stretch. So if I have a number outside of the function, it's being multiplied by that function, then what will happen is the y values will be affected by that number, and the function will be stretched by a scale factor of that value a in the y direction. So essentially the function's being pulled in the y direction depending on the value of a, or squished in the y direction, but we don't use those words, we just use the word stretch. If you've got a number inside the function in the bracket with the x, that stretches the function by a scale factor, but not with a as a scale factor, but 1 over a in the x direction. Okay, and again you can see this in various applications which your teacher will show you in the class, and on my maths as well. Okay, so let's just go through the sort of skills that we need to know in year 12 for transformations. So part A, describe the single transformation by which the second curve can be obtained by the first. So essentially what they're saying is describe the transformation which gets you from there, from the left hand side curves to the right hand side curves. So first of all, what you need to do is you need to analyse what your f of x is. So in part A, our f of x is x squared. Okay, and what's going on is you've got a new function which is adding 3 to that f of x. Okay, look, x squared is f of x. I'm adding 3 to it. So if you've got a number outside of f of x, remember what we said? That's a translation of f of x in the y. Okay? So the graph x squared to x squared plus 3 means the graph will translate upwards by 3 in the y direction. Okay, so if I was to do a really quick sketch, there's x squared and there's x squared plus 3. Okay, you can see that translation there. Right, part B, y equals sine x to y equals sine 2x. So I'm going to make f of x equals to sine x. Okay, and what's happening with sine 2x? Well, what we've got in sine 2x is that the x is being multiplied by 2 inside of the function sine. So we've got to recognise that f of x, which was sine x, is now f of 2x, which is sine 2x. Okay, so that means I've got a number multiplied by x in the bracket of the function, which, if I look at my transformations, will match with this. F of 2x stretches f of x by a scale factor 1 over a in the x direction. So that's, how would I describe it? Stretch by a scale factor of 1 over a, which is a half, in the x-axis. Now what would that look like? When you come to do question 2, we'll sort of do a little bit more work on the x squared. But when you've got sine 2x and it's being stretched by a scale factor of a half in the x direction, well, here's a quick sketch of sine 2x. 0, 90, 180, 270, 360. Okay, and when you stretch that by half in the x-axis, then what's going to happen is it's going to compress. Okay, so these points in section, or these major points are 91. That will happen at 45, 1. This point here, 180, 0, will now happen at 90, 0, etc., etc. So you're going to get a more compressed curve. You have 2 revolutions there. Okay. Right. Part C. Cos x to cos x plus 30. So I'm going to make my function cos x, and I've got cos x plus 30. Again, what have I got going on here? I've got a number being added in the bracket with the x. So I've got my function, and in the bracket with the x, I've got 30 being added to it. Where do I see that in my list from here? Well, I've got it here, f of x plus a, which is a translation of the function minus a 0. So if I've got f of x plus 30, then that means the function will translate by minus 30 degrees 0. Okay, so translation by minus 30 degrees 0. Okay, so the whole graph of cos x moves to the left minus 30. Okay, and D, 2 to the power of x goes to 2 to the minus x. So I'm going to make my function 2 to the power of x. Okay, and I've got 2 to the minus x. So in the bracket with the x, I've got minus affecting it. So I'm going to have minus x. That's essentially what's happened. Okay. So where do I see f of minus x? Right here at the top, reflection of f of x in the y-axis. Okay. Of course, if I was to do a quick sketch, there is 2 to the power of x, and if I did 2 to the minus x, look like that. Okay, so 2 to the power of x, 2 to the minus x. Anyway, that's how we describe transformations. It's a really important skill at year 12 to be able to describe transformations. And the best skill is just to look at the original function in terms of f of x and think, okay, what's happening now after the transformation. Okay, are we adding a number? Is a number being multiplied inside the function? Is a number being added or subtracted inside the function? Or is there a minus inside the function or outside? Okay, and then you've got to think about your different types of transformations. So that's describing. Now we come on to sketching. Okay, so we've got f of x equals x squared, and we've got to sketch these types of graphs. I'm going to do it on different axes. So here's part A. Here's part B. Here's part C. Here's part D. Okay. Now what's really important is first to understand what x squared looks like. We know it looks like that. Okay. So that's why f of x equals x squared. Right, the first thing we're going to start off with is f of 3x. So we've got to sketch f of 3x. And what would that look like? So if I go back to my transformation notes, f of 3x would align with this, f of ax. So it stretches the function by a scale factor of 1 over a in the x direction. So in this case, it will stretch the function by a scale factor of a third in question 2. Now what would that look like in this situation? Remember, if I have a stretch of scale factor of a third, then that will compress the graph. So this graph will look a lot more narrower. Okay? Okay, it will look a lot more narrow compared to what it was originally. Okay? And if we were to write the equation of f of 3x, remember the 3 is next to the x in the bracket, it's going to look like this, 3x squared. Okay? And you can expand the brackets, still get you 9x squared. And that matches up with the graph because for each x value, when x was 1 here, y was 1. Okay? But when x is 1 here, y is 9. Okay, so the graph is definitely compressed in that way. Right, part B, minus f of x. Minus f of x got minus outside the function, so it's going to be minus x squared. So minus f of x, I'll go back to my notes. Then where's minus f of x? Well, that's it, it's a reflection in the x-axis. So the whole graph will be reflected, and you're going to take the x line as the mirror line. Okay. So that's part A, that's part B. So that is minus f of x. What about this one here, f of x plus 2? Well, I've got a number being added outside the function. So I'll go back to my functions here, think, okay, where is it? Okay, I've got a number being added outside the function. Well, that's a translation in the y-axis. So I've got a number being added outside the function, so it's x squared plus 2. Okay, and when you do that, this is x squared, and if you push it up by 2, it's going to look like this. Right, f of x plus 2. And the final one, you've got f of x minus 2 in the brackets. Okay, so what would that look like? You've got minus 2 in the bracket with the x, so that's going to look like x minus 2 squared. And one thing, we don't actually need transformations knowledge for this, although we will do it with using that. If you were to rewrite this, be x minus 2, and therefore cut at 2, sorry. And if you were to expand the brackets, the y-intercept will be at 4. So actually we can sketch the graph just by using our quadratics knowledge. But if I just want to use transformations, f of x minus 2, that would correspond to this layout. Okay, f of x in the bracket, translation minus a. So if I've got x minus 2, that would be a translation of plus a, plus 2, which would mean it's going to go to the right by plus 2. Okay, and that's been shown clearly with me doing the quadratic method as well, so they match up. Okay, as I said, the skill of transformation is very, very important. Practice questions are outlined here. Stretching challenges outlined here as well. So that is the end of the video. Good luck.